When the topic is nuclear energy, few are aware of the benefits of research and development of nuclear techniques and equipment to society. Health, environment, industry, agriculture, and energy generation are the areas that have benefited most by using nuclear technology. Databases about cancer worldwide estimate that every year millions of people succumb to this disease. Rapid and precise diagnosis followed by adequate treatment using radiopharmaceuticals is of immense help in this battle for life.
A oncologia tem observado nos últimos anos inúmeros avanços propiciando aos pacientes melhora na sua qualidade de vida, bem-estar e até mesmo a cura de muitos pacientes. A interface entre oncologia e medicina nuclear é uma das áreas de grande avanço recentes. E novos radiofármacos têm sido incluídos no armamentário terapêutico e diagnóstico utilizado nos pacientes oncológicos. Por exemplo, a aprovação do rádio-1223 em câncer de próstata leva a benefícios clínicos muito significativos para os pacientes e até mesmo um aumento na sua sobrevida. Desta forma, nós esperamos que essa relação entre a oncologia e a medicina nuclear se aprofunde cada vez mais no futuro, podendo trazer muitos benefícios para os nossos pacientes.
Since 1959, IPEN, Instituto de Pesquisas Energéticas e Nucleares, the Energy and Nuclear Research Institute, has been conducting research and manufacturing radiopharmaceuticals for use in nuclear medicine. IPEN produces almost 100% of the radiopharmaceuticals used in Brazil. Radiopharmaceuticals are substances with radioactive elements, and these are used to diagnose and treat malfunctioning organs. More precise evaluation of the clinical state of a patient with the use of radiopharmaceuticals has made nuclear medicine a growing specialty in the last decade. IPEN has two third-generation cyclotron accelerators that produce fluorine-18, among other diagnostic and therapeutic drugs, and this is used in computer-aided tomography examinations. In the IEA R1 nuclear reactor, other radiopharmaceuticals are produced, like samarium-67, a potent ally in the combat of pain, and iodine-131 for the diagnosis and treatment of thyroid malfunctions. Other installations in IPEN produce iridium-92 wires and iodine-125 seeds for brachytherapy. IPEN processes all the molybdenum-99 imported by Brazil to manufacture technetium-99 generators, used in 80% of nuclear medicine procedures. To handle all products for medical use, IPEN has a radiopharmacy center certified by ISO and CNEN and licensed by Anvisa. Daily, these products are distributed to hundreds of hospitals, laboratories, and medical clinics around the country. That means millions of medical procedures annually. IPEN carries out important research on biopharmaceuticals created from animal toxins, hypophysial hormones, and with biologically interesting polymeric material. Besides these, the laboratory animal rooms in IPEN are of the highest standard for breeding and maintaining animals free of specific pathogens under controlled sanitation levels, essential for many types of research. Other studies in the area of health involve the use of laser, from characterization of irradiated biological tissue to development of methods to achieve high levels of disinfection. The latter includes elimination of microorganisms in periodontitis and infected burns. There is also the production of hydrogel membranes, an important ally in the treatment of cutaneous leishmaniasis. IPEN is also involved in research related to the production of clean energy. Since 2000, studies are ongoing with fuel cells, mainly to acquire know-how and technology to produce energy using hydrogen obtained from renewable sources.
O IPEN tem papel de liderança muito importante em pesquisas ambientais no Brasil, sejam elas na área, por exemplo, atmosférica, na área de reciclagem, de desenvolvimento de tecnologias para uso sustentável dos recursos naturais do nosso planeta. O IPEN está desempenhando um papel muito importante no desenvolvimento de novas tecnologias de baixo carbono. Em vista dos recentes acordos internacionais assinados, é fundamental para o país desenvolver tecnologias com menor emissão de gás de efeito estufa e o IPEN tem um papel muito importante no desenvolvimento dessa estratégia de pesquisa para o país.
To analyze the composition of the atmosphere, a high-powered laser is used, which emits light pulses to detect pollutants and other components in the air. Other modern techniques are also used to study atmospheric pollution in the Amazon region. Scientists from IPEN, with the approval from surveillance and control agencies, also map rivers and beaches for possible contaminants, besides finding methods to prevent it from spreading. The aim is to preserve the water sources for human consumption and for recreation. Irradiation of foodstuffs is a safe technique for microbiological control without changing the flavor, color, and nutritional value. This technique extends the validity of dry food and the shelf life of seeds, vegetables, roots, and fruits. Radiation is used to control the spread of insects in leaves and flowers. It is also used to slow deterioration of different types of meats.
A irradiação não só contribui para aumentar a segurança microbiológica do alimento, tornando mais seguro para nós ingerirmos, mas também aumentando a vida de prateleira desse alimento, causando então uma redução nas perdas econômicas.
To gain mastery of this process and to safely evaluate the results, IPEN designed and built a Cobalt-60 multipurpose irradiation device using Brazilian technology. The multipurpose irradiator is also used to sterilize medical and pharmaceutical products, biological tissues for surgical implants, to improve the quality of semi-precious stones, and even in disinfestation and conservation of cultural patrimony. The Brazilian industry benefits a lot by using nuclear technology. Gammography is an efficient tool to identify cracks and defects in metals and is used often by the aeronautical industry to identify possible wastage of aircraft components. It is a preventive method to try and eliminate the risk of accidents. In IPEN, the need to investigate materials in detail has led to the setting up of specialized laboratories to study metals, ceramics, polymers, composites, and corrosion. Another important tool for the metal cutting industry is laser ablation, in which laser pulses impacting metal surfaces result in high-precision cuts. This process, developed in IPEN, has been incorporated on a large scale in industrial production lines and is a routine procedure in several companies. IPEN has two industry-type electron accelerators. In these accelerators, high-energy electron beams induce improvements in physical and chemical properties of materials and finished products. This technique enables strengthening of electrical wires and cables, films, packaging materials, foams, and tires. Besides these, this technique is recommended for sterilization of packaging materials of medicines, cosmetics, and food. One of the objectives of IPEN is to educate students at the graduate and postgraduate levels, providing human resources for the science and technology area. Hence, education has a prominent place within IPEN. Since 1976, IPEN has been awarding MSc and PhD degrees in nuclear technology, and this program is linked to the University of São Paulo's USP postgraduate program. Excellence in this area, as evaluated by CAPES, has attracted an increasing number of students to IPEN to pursue postgraduate studies. IPEN provides scholarships for all levels, from undergraduate to postdoctoral, and also offers elective courses for undergraduate students of the University of São Paulo. The IPEN MB01 research reactor is the first genuine Brazilian reactor. It was designed in IPEN and built by the Brazilian Navy. It started operating in 1988 and has been an important investigative tool, as it is capable of closely simulating nuclear characteristics in larger reactors. In this reactor, scientists can test a typical core that can be used for naval propulsion. The IEA R1 pool-type research reactor in IPEN went into operation in 1957. This reactor is used to produce radioisotopes, radioactive sources for industrial gammography, for nuclear physics experiments, and for training personnel. The fuel used in this reactor, as well as in all other Brazilian research reactors, is manufactured in IPEN. Constant research to develop new nuclear fuel technology, to increase production capacity, and to assure final product quality is a routine task within the Institute. Presently, IPEN is contributing its advanced know-how in the nuclear area by actively participating in national projects like the Brazilian Multipurpose Reactor, RMB, and the use of ultra-high-powered lasers. To protect humans, other life forms, and the environment, IPEN is involved in safe management of radioactive waste produced in Brazil. With a view to guarantee safety, continuous activities include characterization, treatment, and final disposal of waste, as well as continuing research to reduce volume, treatment time, storage, and repository capacities. Other concerns of IPEN are safety of its employees and the population at large, development of standards and methods to measure radiation, safe handling of radioactive elements, inspection, and aid in the case of accidents. Founded in 1956, IPEN occupies an area of 500,000 square meters within the campus of the University of São Paulo. It is linked to the São Paulo state government and since 1982 managed by the Brazilian Nuclear Energy Commission. To carry out the research programs, develop products, and offer services, IPEN is organized as centers, has an Office of Innovation and Technology, as well as an administrative structure and offices to look after its campus. The operation of IPEN has always been guided by its constant drive for excellence and by its commitment to attend to demands. It thus offers the benefits of its scientific and production capabilities to all segments of Brazilian society. Nuclear technology is an area in constant expansion. Presently, the production, use, and management of nuclear energy are essential for society. IPEN's obligation is to generate know-how, develop new technologies, and prepare professionals capable of significantly contributing to improve the quality of life of Brazilians.